6.7 is solving radical equations. That means equations with a radical in it, or a lot of times we look at it as square root equations. All we have are square roots here. So the first thing you want to do is isolate the square root, and that's kind of the key. And then you're going to square both sides. To get rid of the square root. Square root squared cancels out. That's what we're trying to do. So isolate the radical first, then square both sides. Let's look at example 1. Number 1, we want to isolate the radical. I mean, get it by itself. And so what we want to do is get rid of this 2. So I'm going to subtract 2 on both sides. Doing that cancels out 2. 2 minus 2 is 0, so that's gone. I'm left with the square root of n minus 5 equals 6 minus 2 is 4. So I have the radical by itself on one side. Isolate the radical. That's what I wanted. And now I'm going to square both sides. Squaring both sides, or squaring a square root, is going to get rid of it. So when I say square root squared, it kind of just cancels out. And I'm going to be left with n minus 5 there, equals 4 squared is 16. At the end of the day, we're just solving an equation, and we do what we always do. We isolate the variable. So let's add 5. We get n equals 21. Number 3 is a little bit easier because the variable, or I mean the radical is already isolated. The radical is already by itself on one side, so all we're going to do is square both sides. Square both sides, we're going to have 4 equals 3r minus 2. And then we just solve. We do what we always do. We're going to add 2, and that says 6 equals 3r. And then to get r by itself, we're going to divide by this 3, both sides. We get 2 equals r, or r equals 2. Number 5, if we want to isolate the radical, that means we have to get rid of that negative 6. Now, pay attention to the operation. That does not say subtract 6. It does not say subtract 6. That is a multiplication problem. Times, right there. Negative 6 times the square root of x minus 4. So in order to isolate, we have to undo operations, and you undo the times with divide. Undo multiplication with divide. So we're going to divide both sides by negative 6 here. Of course, that's going to cancel, leaving me with square root of x minus 4 equals negative 48 divided by negative 6 is positive 8. And again, I've got the square root by itself. Square root by itself, we're going to square both sides. That cancels out the radical, gives me x minus 4 equals 8 squared is 64. Add the 4 over. X equals 68. Make sure you're showing your work. Every once in a while there's a step you can skip, but I'm showing you exactly what I want, okay? So pretty much do what I've got here. Number 7. Again, keep in mind what you're trying to do. You're trying to isolate that radical. And so in order to do this, we're going to have to get rid of this minus 2. That's a subtract 2. I get rid of subtract 2 with a plus 2. I'm adding 2 to both sides. The reason I'm doing this is to cancel out that minus 2. Negative 1 plus 2 is positive 1 equals the square root of b over 2. I've got the radical by itself. That's what I want. Let's square both sides. 1 squared is still 1. Square root squared cancels out. I'm left with b over 2. We're trying to isolate the variable. So this is divide, right? You cancel out division with multiplication. So I'm going to multiply both sides by 2. The whole point is I'm trying to cancel that out. I'm trying to get b by itself, and I did. 2 times 1 is 2. That's my answer. Or you can rewrite it, b equals 2. Number 9. Number 9 is kind of weird because you have a square root on both sides. All right. You can't really isolate a square root because there's 2 of them. There's 1 on each side. But what you can do is if you notice that this square root is by itself on the left and there's a different square root that's by itself on the right, you can just square both sides right now. Squaring both sides is going to cancel out both of those square roots. Square root squared cancels out, you get b over 2. Square root squared cancels out, you get 3b minus 25. All right, now we need to try to isolate the variable, but again, we have 2 variables, so we need to get them on, get the variables together on one side. The fraction, a lot of people don't like to deal with that fraction, but I've got a trick to get rid of fractions. I call it defractionizing. Basically, whatever the fraction is, divide by 2. If you want, let's multiply everything by that denominator. We're going to multiply all the way through. We're going to multiply everything by 2, and that's going to cancel out and give me b equals 2 times 3b is 6b. Careful, your 6's don't look like your b's. Minus 2 times 25, 50, right there. Okay. So think of this as 1b if you'd like, but however you think about it, we need the b's together. I'm going to subtract 6b to get my b's together. Again, I'm trying to cancel this out. I'm trying to get my b's together. 1b minus 6b, that's negative 5b, equals negative 50. So we're going to divide by the negative 5 to cancel out. B equals negative 50 over negative 5 is positive 10. I don't have much room on number 11, but it's pretty much the same thing, right? You've got a square root on both sides. Square root on both sides, so let's just square both sides. Square both sides. And the square root goes away. I've got 3x plus 33 equals negative 3 minus x. Again, I've got some like terms on both sides of the equation. I want to get my variables together. I always do the variables first. You can do the numbers first if you want, but I think it's more efficient if you do the variables first. I always get rid of my smaller variable. This one's smaller, so I'm going to add x to both sides. I think that's the most efficient way of doing it. You can do it other ways, but this is usually going to be the fastest. Get rid of your smallest x. So 3x plus x is 4x. Got this plus 33 equals negative 3, and that's canceled. That was the whole point. I'm going to move this over here. I had 4x plus 33 equals negative 3. And this is just a regular solve. I want to get x by itself. I want to get my variable by itself. So let's isolate. Let's subtract 33. 4x, that's gone, equals negative 3 minus 33 is negative 36. I'm going to divide by 4 to get x by itself. Looks like x equals negative 9.